What's up everyone, we on A-Level Mechanics. This is a revision. We continue doing vertical motion under gravity, so you take into account the only single force that acts on your projectile, on your particle, whatever you surround vertically. And this is not a projectile motion like under specific angle. This angle is basically 90 degrees. You're thrown either upwards or downwards. Okay, and we're gonna go to the problem 2. So that was 3 main formulas that we apply whatever problem we have, and actually that was the problem 1. If you haven't seen the previous videos, okay, make sure you can do such problems. If you're not sure, here is a quick solution for that. And we go to the problem 2. Okay, so the problem 2 is a bit harder. It's bounce off problem. When you throw the ball or whatever like object that can maybe partially elastically collide with the surface, with the ground, and bounce off, every time it loses energy, right? This is the principle of physics. So every time kinetic energy is not restored to their same previous value as it was like during the release of the ball. So every time decreasing, and as you can see here, 10% of speed is lost when it bounces off. Okay, so that's an idea. Read carefully, try to do by your own, and let's have a look how it can be done. Okay, so well, the problem is not really complicated if you start considering it and maybe in a systematic way. So just let's see what's happening. So here is initial height, right? Point in part A. So here is initial height, and we input x-axis, let it be x-axis, and here's gonna be the ground. Okay, here is gonna be the ground surface. All right, so it starts releasing, and it's released from rest, means initial velocity 0, but anyway, it's released from the rest position, which is at height of 12 meters. Okay, and it goes down before it collides with the surface. It hits the surface, then the speed is lost. So you need to find the height above the surface reached by the ball when its first time rebounds off the surface. So that means its initial height, and after rebounds, it will lift up, but not to the same surface. Not to the same height. Let it be height h1 that this ball reached after rebounding. Obviously, you need to know their initial speed during the rebounds. Okay, this u1 is the speed after losing 10%. Okay, so that means it's 0.9 or 90% out of the speed that it has before, right before a collision, after falling from the height of 12. So that's going to be 0.9 times v. And in order to find u1, okay, first of all, because obviously from there we can calculate the height 1, which is simply u1t minus gt squared over 2, or maybe it's easier to use another formula, because in this case you need to know the time, so that's why it's better to use this formula, which is u squared over 2g. Both use minus sign, so I'll cancel them, because the final velocity at this point is gonna be 0, so that's sort of v at the point in time when it reaches h1. Okay, I just put h1, and this velocity and the speed itself is 0. Okay, because this is the maximum height that reach up to the bounce. So we can calculate using this formula, and u1, actually I just need to correct a little bit. So u1 is the initial speed after the first bounce. Okay, so that's why first we need to find this v, and when it's possible we can find the final h1. All right, so let's calculate v just right before the collision. So maybe it's better to mark the points like 1. If I input indices, it won't be useful. All right, anyway, so v at this point is gonna be calculated as, because we're given height, Yes, so we can use the formula for V through the height. So h is equal to v squared over 2g, okay? Because again, initial velocity here is 0. So at this point, it's 0. So that's why we just left with that one. We can calculate v as square root of 2gh. And so we're going to use g equals 10. So we can just plug in and write, so 20 times height, which is 12. And that means we can calculate straight away. All right, so let's use calculator, and it's going to be 20 times 12 and the square root of that. So I've got around 15.5 to 1 decimal place. We're not stated, so that's why I'll give the answer to 1 decimal place. Let be 15.5 meter per second. All right, so we've got this value. It's right here, and that means U1 we can also calculate because it's 0.9 from that. So we just times by 0.9. It's going to be 13.9 meter per second. That's going to be U1. So from here, we can calculate the height 1, which is U1 squared over 2g. So it's going to be 13.9 squared over 20. And right now we can calculate this with no doubt. All right, so we just raise up into square and divide it by 20. So I've got 9.72 meters. If you're if you stay that 10% decrease in speed, so it's going to be 10% basically decrease in height. So it means you just can't subtract 1.2 as 10%. It wouldn't be correct, right? Because look, right now we can estimate h1 to the initial height, which is actually 972 to 12. And if you calculate that, just divide simply by 12, I've got around 0.81. So it means that the ratio represents 0.81, so that means more than 10% loss in height, okay, during the bounce off. All right, hope you understand that speed 10% decrease, 10% lost of the speed is not equal to 10% lost or loss in height, okay? Make sure you understand this. Okay, so second time it rebounds the surface. Now, what we can do, we can apply the same approach, and simply we can just say that u1 squared becomes u2, okay? So that's going to be now u2 squared over 2g. Okay, and now we need to understand what's u2 in terms of u1, okay? We've calculated u1 as 13.9, and I'll just maybe draw the picture a little bit here, small picture, which means that right now it bounced off the second time. So that was initial height, that was second, that was the first bounce off, and here is going to be the new one, which obviously smaller, okay? And this is the surface ground. So initial speed when it bounces off is going to be u2, which is going to be again 0.9 from u1, right? That's the fact, because when it bounced off with u1, it reached back with u1 again, okay? That's this principle of symmetry, because the starting speed becomes the final speed when it goes from h1 back to the surface again. So that means it approached with the u1 that was originally during the release, okay, after the first bounce. And obviously u2 is going to be 0.9 of u1, so I hope you got it. 0.9 of u1 squared over 2g. That's going to be the result. So right now we can calculate this. We've calculated 17.9, so we've got this. 0.9 times 13.9, which is going to be squared and over 20. Why I marked H1 is obviously it's going to be H2, okay? It's going to be H2, sorry. Because this is the height after the second bounce. So it's going to be H2 equals, and let's quickly calculate. 13.9, which is going to be squared everything, and over 20. So what I've got 7.82, 83, so 7.8, okay? 7.8, that's going to be the second height after second rebounds. All right, so hope you got it. It wasn't really confusing. And we'll move to more challenging problem that's actually challenge. Because right now we are going to consider particles interaction when several particles released from different points and they meet at one single point.